Geotrig, lesson 22. This is the second half. We're going to talk about reciprocal functions. Reciprocal functions basically, I'm going to call it rational functions at this point. So I'm giving you guys steps for special types of rational functions. So let me take this out of here because these steps will work for more than just reciprocal functions. So rational. So these are rational functions, guys. Yes, it can be in the form of 1 divided by x, as you can see here. But what it's going to come down to is it's going to have something like f of x. So it's going to be a function itself. It's going to be made up of something like g of x over m of x. It's going to be basically a polynomial divided by another polynomial. Okay? So you might have something like 1, because 1 can technically be called a polynomial, over x. X is a polynomial. You could have something like x squared minus 2 over x plus 4. We're going to be able to graph these things. Now the one that I have on here now, that last one of x squared minus 2 over x plus 4, is a slightly different than what we're going to have to do. It's just an example. We will graph ones that are actually going to have a larger degree on the bottom than it will on the top. We're going to start off real simple, real easy, to make all of our steps just be uniform. If it changes, now what do I mean by degree? The degree of a polynomial. What's the degree of a polynomial? Everyone should know this. What's the degree of the top polynomial here? What's the degree? 90. No. What's the degree of this polynomial?
-2.
It's not -2. It's 2. It's the highest power, right? The highest power in a polynomial is considered its degree. The bottom has a degree of 1, because it's not there, it's implied to be a 1. Now, in this particular problem, the degree at the top is 2, the bottom is 1, so therefore the top degree is larger than the bottom degree. That's a situation we're not going to handle right now. We're going to switch that, okay? So maybe I'll just switch it now. Is what happens if I change this to x minus 2 divided by x squared plus 4. Now the degree of the bottom is larger than the top, yes? Now, let's think of this. If I let x become very, very, very large, as in you start putting larger and larger numbers in, the top, which is x minus 2, gets very large, right? 1,000 minus 2, 10,000 minus 2, 1,000,000 minus 2. It's getting larger, right? Everybody can agree.
Yeah.
But what happens with the bottom? X squared plus 4? What gets larger faster? X or x squared?
X squared.
X squared. So what happens here, guys, is as I am making my largest number larger and larger and larger, I'm going to have a large number over an extremely large number. And as I keep dividing those, I'll get closer and closer to the value of 0. So, we're going to have to say that we will have an asymptote. And that asymptote, guys, does anybody know what an asymptote is?
No.
You guys should have dealt with this last year. Lines generally will curve on these ones. Yes, but why?
Because there's the line. The origin?
No, there's a line that you will approach.
There's a line and then there's a curve.
Right. Tyler is correct. There's a line and it curves as it approaches. We need a little bit more though. An asymptote, guys, it can't touch, is a line or curve, a graph approaches but never touches or crosses. Now guys, I'm going to let you in on a little secret. This is a rule, and generally rules are not to be broken, but they happen to be broken. Kind of like what I'm seeing now. So yes, this is a rule. It will be broken, guys. Because an asymptote, what we need to maybe put on the end of this is that it won't touch or cross it at the end. Or at the ends. End behavior. You guys should have talked about end behavior at some point now in the last couple of years. End behavior, guys, of graphs is what's happening as x gets very large or very, very small. As in negative, right? Positive infinity, negative infinity. So at those places, it'll approach it. But if you're someplace close to home, around 0, 0, graphs can actually cross horizontal asymptotes. Vertical asymptotes will never be crossed. And you will have vertical asymptotes, the next line, where blank equals 0. Basically, when you have a fraction, you can never do what? What will a fraction never be able to do? There's like one type of fraction, or even looking back up to this problem, what can x never be? 0. Why cannot x be 0? Can't divide by 0. So, a vertical asymptote is where the blank equals 0. The denominator, or we'll say bottom of the fraction equals 0. You can never be that. So in this case, way up here, x is the only thing on the bottom. So you would have a vertical asymptote at 0, because it can't be 0. This one way over here, can the bottom ever actually become 0? Can you square a number and then add 4 to it and get 0?
Because any negative.
Yeah, because any positive or negative number when squared becomes positive, and you add a positive, you're above 0. So therefore, there would be no vertical asymptotes on this graph. Kind of interesting. Now, how do you get these types of things? You would have to factor, set them equal to 0, and all of that. So, what we have to graph these fantastic rational functions are 6 steps. And actually, I'm going to add one more way at the beginning now that I just said something about factoring. I think the very first thing you should probably do, and squeeze that into here, is factor everything. I want you to factor everything. And then we're going to find the vertical asymptotes by finding what the bottom can't be. The bottom cannot be equal to 0, so therefore we'll know where our vertical asymptotes are. For us, there's always going to be a horizontal asymptote because, like I was talking about earlier, the bottom degree will be larger than the top degree. So we're going to say for now, y equals 0 is also an asymptote. As you guys progress on, and next year for sure, when you guys take pre-calc, we will be dealing with other than y equals 0. There's 2 other cases. And maybe potentially this year yet. Then, I want you to find your x and y intercepts. X-intercepts, not too bad. Set the top equal to 0. And all y-intercepts have something in common. 0 is x. So just plug a 0 in for x and solve. Now granted, could we do that here on 1 over x? No, because they have a vertical asymptote there. So there would be no y-intercept. Guys, once we've done all of this, actually, I realize that we also need to put another one in here, because it doesn't make sense just to make t-charts. Put another one in here. Plot info. Put it all on the graph, guys. I want you to factor it, find your vertical, horizontal asymptotes, x and y intercepts, and then once you have all of that fun information, I want you to put it on a graph. Asymptotes, guys, go on as lines, dotted lines, because it's part of the graph, but it's not really part of the graph. If we were to use a graphing utility, like a graphing calculator, Desmos, you would not see an asymptote on your graph. You would see the effects of it, but you would not see the actual asymptote. But we're going to put them on there as dotted lines to help us guide us. Then, once we have all that plotted, we're going to make t-charts for sections. These sections, guys, are based off of, so maybe put it like this, based off of vertical asymptotes. We're going to base it off the vertical asymptotes. If you have one vertical asymptote, it breaks your x's into two groups. Make two t-charts. If you have, as you can see, watch, I'll draw a little diagram here. If this is a vertical asymptote there, that dotted line, hopefully you see that I got the left side, and then I have a right side. That's two sides. I'll make two t-charts. If I happen to have two vertical asymptotes, how many sections are there? Three. I got the far left, I have a middle, and a far right. If there are three vertical asymptotes, what do I do? One, 2, 3, 4. It always seems to be one more t-chart. I am going to pick values, guys, x values, that are close to the asymptotes and then work your way away. If you're in the middle, pick one on kind of close to each side, maybe a point in the middle. Therefore, we can see our asymptotes in action. We're going to approach them. We're not going to cross them or touch them. Okay? And then once you have your t-charts filled in, you plot them, you can draw the curves in their places. So now we're going to move on to examples. I am not going to give you this list on your quiz. Top equals 0, bottom equals 0, factoring, plug 0 in, y equals 0 for us all the time, making t-charts, all of that is going to have to become second nature. There'll be more and more problems. So here we go. I gave you an example of y equals 1 over x or 1 over x, so let's actually graph it. What does it look like? This would probably be what we're going to consider one of the most simplistic rational functions that you can have. So let's look at our checklist. The first thing on our checklist is factor everything. Do we need to factor this? No. So technically step 1's done. Step 2, or the step 1 that was already listed, would be then now what? Okay. Vertical asymptotes. So this is what I like to do. I like to actually write vert. Vert means vertical asymptotes. I'm going to set the bottom equal to 0. So sometimes I even do this. I state exactly what I am going to do. I'm going to state that I am going to set the bottom equal to 0. And when I do that, it's x equals 0 and solve. Oh wait, it's already solved. What's my vertical asymptote? X equals 0. X equals 0. It's different than 0. Because the next step says what? Horizontal asymptote. Okay? For all of our problems, it's going to be y equals 0. For now. So you just state it. Next one. X-intercept. So I'm going to put X-intercept. And the rule for that one is set top equals 0. Oh, what's the top?
0.
It's 1. Does 1 ever equal 0?
No.
So there are
No.
none or no x-intercepts. Is that okay? Sure. Not every graph is the same, right? Some have them, some don't. Next one. Y-intercept. And that one is let x equal 0. Here's a problem. Can we let x equal 0? So 1 over 0? Yeah, no. So therefore, none. Oh man, this is not really shaping up to be too good here. We don't have much to put on the graph, right? It's still okay. So anything else we need to find? Now we got to plot that information first. Then we'll make t-charts. So here we go. I'm making a graph. I suppose I should make that larger. Didn't realize that. Okay, hold on. Okay, we made it larger. Let's start plotting our information. We have a vertical asymptote at x equals 0. X equals 0 is what kind of line? Don't say straight. It's a vertical line, yes. So I'm going to put a vertical line at x equals 0. I changed colors so you could see it. We also have a horizontal at y equals 0. So now we have our vertical and horizontal asymptotes. X and Y intercepts, there are none. So therefore, I'm done with my plotting stuff. So what I need to do now is make a t-chart. I'm going to make 2 of them because we have one vertical asymptote. Something's going to happen on the left side of that vertical asymptote over here, and something's going to happen over on this side. Okay? What are some nice values around that vertical asymptote? 1, 2, 3. What about -1, -2, and -3? Would that be okay? I can't put 0 in because I can't divide by 0, right? So what happens when I put 1 in? 1 divided by 1? 1. 1 divided by 2? 1/2. 1 divided by 3? 1/3. So, wait. So you're saying that it's 1, 1, 2, 1/2, and 3, 1/3, right? It's a little harder to see that one, I guess. But I'm cascading down, but not falling at a consistent rate. Can you see that? So if I had to connect these points, they look like this. But here's the thing, the graph doesn't stop. I can put 4, 5, 6, 7 in, right? What's going to happen is that it's going to keep getting closer and closer and closer to 0. Here's the thing. Can it ever become 0? Take a look at that equation. 1 divided by something. Tell me the number that when I divide 1 by it, I'll end up with 0. Can't divide by 0. So that won't work. Can I divide it by 1,000,000?
Yes.
Will it actually be 0? No. If I had a pan of brownies, guys, and I cut it between 10 people, everybody gets a piece, right? If I have 100 people in that same pan of brownies, technically everybody could have a piece, yes? Now, eventually, that piece is going to be so small that it's not going to be worth having everybody have some, right? But I could take some kind of magical scientific device and cut it in pieces down to its electrons and atoms and stuff and still give somebody something, right? It'll never be nothing. There's always something I can cut in half. And the same thing happens here. I can divide by half. I can divide by something even smaller. But if I start to divide by fractions, the number gets larger. What's 1 divided by -1? 1 divided by -2. -1/2 and then -1/3. Yes, same thing happens on the other side. Notice they're in opposite corners. I'm not going to say that will happen every time, but it happens a lot. Okay? Things happen on opposite corners of each other there. Okay, we're going to step it up just a little bit. It's 1 over x squared. The degree of the bottom is 2. The degree of the top is 0. It's a constant. So the bottom definitely is bigger than the bottom. Or bottom is bigger than the top. So therefore, y equals 0 is still there. Go through the rest of the steps. See if you can do as much as you can without looking back. We'll come together to graph this. So, first thing, vertical asymptote. X squared equals 0,
Oh, yeah.
or x equals square root of 0 plus or minus, really, right? But what is square root of 0? 0. So we still have x equals 0. Interesting. The horizontal asymptote, same. Y equals 0, right? Now we have to go to x-intercepts. Setting the top equal to 0. Again. None. Y-intercept. 1 divided by 0 squared. None. Okay. Wait a minute. Mr. Concheck is exactly what the information we had last time. Right? I mean, everything listed so far, you guys wouldn't be able to tell the difference. So when we go to graph this now, we have a vertical and horizontal asymptotes at 0, right? Awesome. How many T-charts do I make? 2 T-charts. Hey, look at this. What kind of information am I putting in? What values? 1, 2, 3 again. 1, 2, and 3. So, negative, sorry. 1 squared is, so 1 divided by that 1 is 1. 1 divided by 2 squared is 1 divided by 2 squared. 2 squared is 4, so it ends up being 1/4. 3 squared is, so it's 1 divided by, this actually seems like it's getting to go to 0 faster, isn't it?
Yeah.
Going to the other side, 1 squared, or negative 1 squared is,
1.
so 1 divided by 1 is still 1. Ooh, wait, that's different. Negative 2 squared. It's 4. It's a positive 4, so you end up with a 1/4. Negative 3 squared, so it ends up being positive 1/9. Whoa. So when I go to graph this, 1, 1, 1/4, 1/9, this looks exactly, well, not exactly the same, but it looks pretty close to the same, yeah? Granted, guys, I can't do 1/9. 1/4 maybe I can get closer to, but I'm just kind of eyeballing it there, right? But wait a minute. Going to the other side, it's negative 1, 1 again? That's different than last time. This one goes like this. They're both on top. Why does that happen, guys? Because I'm squaring a number, and when you square a number, it becomes positive. Okay? Cool? Okay. I want to change up the next problem to make it look a little bit more different so we can see a little bit of the intercepts going on as well. I changed it from what the outline says, but I made it x minus 2 divided by x squared minus 9. Can you guys see that the top degree is what? 1. Bottom degree is 2. The bottom's bigger than the top, so that means we still have a horizontal asymptote at 0. Still staying within our means here. So, I'm also going to pause the video on this one. We'll come back to work on it, but I want you guys to try this one on your own. This one's going to have to make you find an x and y intercept using the setting the top and bottom and all of those things equal to 0. So let's go through our list here, guys. The first thing we wanted to find was our vertical asymptotes. Our vertical asymptotes are what make the bottom equal 0. And so x squared minus 9 equals 0. Wait a minute. This might actually be our first problem that we actually have to enact step number 1 that I added. Is this problem completely factored? No. So wait, I'm going to take away that, and I'm going to go back up here. Can I factor x minus 2? No. Can't factor x minus 2, but can I factor x squared plus minus 9? Everyone should be able to say, yes, that is the difference of squares, and it becomes x minus 3, x plus 3. So now when I go and say, what's my vertical asymptote? I'm asking myself, when does x minus 3 times x plus 3 equal 0? When either one of those groups are equal to 0. The zero product property, when two things are multiplied that equal 0, one or both of them have to equal 0. So the only way to get 0 by multiplication is if one of them is. So we always say x minus 3 equals 0 or x plus 3 equals 0. In the first case, x would have to be 3. In the bottom case, it's... Okay. Now, this is where I want you guys to realize that if I left it as x minus 3, as a mathematician, I'm thinking that's a vertical line at 3 and a vertical line at negative 3. Now, as soon as we say, hey, I have an x-intercept, guys, at 3, we all know where to look, right? But if I wanted to state this correctly, we should be stating them as points. What would the point be for an x-intercept at 3? 3, 0. It would also be negative 3, 0. This is what I have to plot eventually. Okay? Now we can go to our horizontal. Y equals 0. We already talked about that. Now we can go to our y-intercept. Wait, guys, I messed up. I just got carried away with trying to explain things, guys. What did I find in the very beginning? What are these things? Vertical asymptotes. Vertical asymptotes are lines. X equals 3 and x equals negative 3 was the answer, guys. I went too far. Then I started talking about x-intercepts, guys. Sorry, that was my bad. I'll take ownership of that. Okay, guys, let's go back over this. We set the bottom equal to 0 because we found out what x values can't be because they form vertical asymptotes or vertical lines. X equals 3, x equals negative 3 are lines. We're good. That's it. Stop there. Y-intercept. These can be done out of order too. How do I find a y-intercept? Set x equal to 0. Here's the cool thing, guys. Watch this. I'm going to show you guys the long way the first time. I'm actually going to plug in 0. But what happens with 0? It makes things go away, huh? So that's just negative 2 over negative 9, which is 2/9. Wait a minute, guys. If I wouldn't back up to here, couldn't I just cover up anything that has x's in it? And you got negative 2 divided by negative 9, which is 2/9. Okay. Now, guys, I don't want to leave this as y equals 2/9. I need to write this as a point. 0, 2/9. I plugged in 0 for x and got 2/9 out. X-intercept. Set the top equal to 0. Sorry, What happened was, remember, we started talking about how to find the top equals 0. I ended up starting with vertical asymptotes. That's what got us all mixed up. Or me mixed up. Add 2, x equals 2. But I'm not leaving it as x equals 2. It's an x-intercept at 2, which is 2 comma 0. Because I don't want to get this mixed up with that. Vertical asymptotes, x-intercepts, not good to get mixed up. Now we can graph it, guys. So, we have a vertical asymptote at 3 and negative 3. How many t-charts? 3. Good. Y equals 0. And now I'm going to start plotting my intercepts. 2, 0. Well, that's right there. And 0, 2 ninths. That's all I got. I got to fill in the rest. Hey, question. This is a horizontal asymptote. This is an x-intercept that's crossing it? What did I say about that? It's okay when it's close to home. That's okay. Now we got to make our t-charts, guys. I'll make one for over here. We'll make one for in here. And we'll make one for in here. Or all for the side. What are some values for the far right?
1, 2, 3.
So
No.
4 and 5.
Yeah, no, it's 5.
Okay. The middle? Hey, look at this. 2 is 0 already. 0 is 2 ninths. And let's just put in negative 2 to find out what that is. That'd be kind of interesting. And can I use negative 4 and negative 5?
You don't need 3.
I don't need 3.
Okay.
I used 3 because I wanted you guys to see that as you get closer and closer to an asymptote, or further away, you'll get closer and closer to an asymptote. Let's start off with the middle one. Now some of this, guys, you have to do a little bit of thinking. When I put negative 2 in, it's negative 2 minus 2, which is what? It's not 0. So I'm going to go over here, guys, and I'm going to write negative 4 on top, put a fraction, so that way I don't have to remember everything. And then I'm going to go to the bottom. Negative 2 squared. 4 minus 9. It's negative 5. And that's a negative divided by negative. So it's a positive 4/5. Oh, so actually, guys, that's almost close to 1. So at negative 2, I'm on the way back up. So where do you think that one's going?
Whoa.
Yeah. Bless you. There's your middle.
Well, it's just
Kind of looks interesting, doesn't it? Then we got to do the sides. Let's put 4 in. 4 is a nice number. What's 4 minus 2?
2.
So it's 2 divided by 4 squared minus 9. 16 minus 9?
Yeah, 60 minus 9.
7?
7.
Okay.
Wow, that's
5. 5 minus 2 is 3. 5 squared minus 9. 16. 2 sevenths 3/16. Oh my! I don't know if my graph can handle this because I'm not, my scale's not good enough.
It's okay.
But is 2/7 bigger than 3/16?
Yeah.
Yeah, I think so. So you know that they're actually starting to fall as you go away, right? So that means this one also does this. What's -4 minus 2? -6. What's -4 squared? Minus 9. So this is a -6/7. That's pretty close to -1. Okay. -5 minus 2. -7. 5 squared. All over 16. So that's about half, right? So somewhere about -1. -1-ish. So it looks like there's your graph. Some pretty cool stuff. So guys, worksheet for your homeworks, first side. Have a great day.